The agenda for today's training series would be the reason which cause slowness to your business web application, analyzing the individual components for the performance issue. Then we'll be moving to the SQL queries, which creates performance related bottlenecks, and finally some insights about measuring the end user satisfaction levels of your applications worldwide. Let's see how a web application is modeled. As you can see in the right hand of this image, web server like Apache, web app components like Java, .NET, Ruby on Rails, and SQL DBs like MS SQL, Oracle. All these components were tightly integrated with each other to keep your application up and running. In today's webinar, we will be discussing on monitoring your application's behavior end-to-end, including the end user experience. As you can see, the end users access your application from a web client, that is a browser. We will be accessing your web application and measuring your web application's performance from a real browser. We will be discussing in the fourth part of this webinar. So let's see how you can say no to the application performance problems. Have you ever seen an increase of your user escalations and complaints about slow apps or poor performance? Are you getting intermittent alerts that you can't troubleshoot? If yes, then it may be the time to arm yourself with a comprehensive performance monitoring tool. Organizations in business to business and business to customer environments find it difficult to calculate the business impact of the performance issues. Recent studies, in fact, indicated that organizations could lose a significant part of their revenues just due to 1 second of delay as per their defined baselines. Let's see the common reasons why your application might be slow. If the web server is overloaded with too many requests from the client, that could in fact cause the slowness to your application. The slow server, which the server teams don't like to hear. Applications developed on a fast LAN with a small data set seem to operate smoothly in your test environment, but once rolled out to the production, the database continues to grow, which may in fact cause a slice of death in the database as well. Recent studies in fact indicated that organizations needs to monitor their database, their application codes, and memory management and thread configurations is one of the key important factors to be considered in the application's performance management. Let's see the few KPIs in application performance management. Apdex score, average response time, request rate were few KPIs which is required. Application performance index score and response time were most widely used metric of the performance, which is a direct measure of how long it takes the web server takes to process your request. Again, throughput is one of the other requests, which is a straightforward count of the number of requests that the application can process within a defined time interval. Understanding how much traffic your application receives can be useful to correlate to your application's performance to understand the dynamics of how your application scales. The more users sends to the more requests your application receives, higher the load is. Let's see the various technologies supported by APM Insight. It supports Java-based web applications, .NET, and Ruby on Rails. The APM Insight architecture is designed in such a way that the agent is deployed on the machine where your application server is running. Say, for example, you have a IIS server running in one of your client machine, and this agent needs to be deployed in that particular server. Once the agent is deployed, the agent hooks up with your application server process and collects the performance metrics and sends the collected data to the data collectors of the applications manager. Once deployed, these agents monitor every line of code, including every transaction from start to finish, even in modern and distributed applications. We use bytecode instrumentation for fetching these data. So Applications Manager provides you deep insight into your web application provides, thus by providing you a whole new dimension of your web application performance and deeper insight to optimize your web application by finding the bottlenecks like exceptions, identify the slow queries, and address those inefficiencies and speed up your application performance. And thus by you in fact get a comprehensive view on your DB operations as well. So Applications Manager provides you a comprehensive dashboard for your web applications. When performance anomalies are detected, APM Insight automatically captures the transaction snapshot, thus includes the code level diagnostics, database calls, stack traces on a single pane of glass. You will see the correlation between your application behavior and performance thus by enabling you to quickly identify the root cause of an issue and visualize the transactions which are affected so that you can ensure to provide flawless customer experience. Let's see how the agent can be installed. Now we will be discussing about the .NET agent installation. The steps were pretty simple and straightforward, so let me skip the installation step. Once the agent is installed, you have the configuration page available wherein you have to specify the host name or the IP address of the applications manager machine and the port number. If you're not sure about the port number, you can open the applications manager installation directory and open a specific file called amserver.properties wherein you will be able to find the port number and you can use that specific port value here. So once the agent is installed, you can able to in fact customize the agent based upon your business specific requirements, like changing the apdex threshold. If you would like to capture the database SQL queries, you can enable or disable it, transaction tracing, and parameterize SQL and transaction traces. Say for example, if your SQL query contains any confidential data, that's where you can use the parameterize SQL option, which is highly recommended in that case. And sampling factor is an important point to be noted here. If you provide the value as 5, every 5 out of 1 transactions will be captured and you can see all those data available in the APM Insight tab. Let's see how you can measure the end user satisfaction levels using the apdex score. So when talking about the apdex score, which is an open standard to measure your user satisfaction regarding a web application, it is a metric that provides a single score ranging between 0 to 1. 0 indicates that no user satisfied, 1 indicates that all the users were satisfied with the business application's performance. This gives a greater visibility to the business owners and insight into the measure of their customer happiness and satisfaction levels. If you are building a software application, either it could be a big or small, your users are going to be the lifeblood of those applications. Understanding the impact of the performance on user satisfaction and retention is a crucial part of building a successful business. So it is important to monitor the apdex score. Let me switch back to the UI and discuss and get some hands-on training on what we have discussed. We are in the Applications Manager UI web console. So let me click the APM Insight tab here and go to the one of the applications. Here you can see the apdex score, and this apdex score is again split into 3 different components, that is satisfied, tolerated, and frustrated. As you can see in this image, 99.3% of the users, whoever is accessing the application, were happy with the performance of this app, and 0.4% is tolerated, and again 0.2% is frustrated with the performance. And most important key metric again is the average response time of your web application. If the average response time is high, that's where the user face slowness with the application's performance. And throughput is again an important factor, that is 1.12 requests per minute and the request count. And if there is any errors, that will be displayed in the errors category here. The historical value is depicted in the form of graph, which will help you to analyze the application performance over a certain period of time. Say for example, if you are having a production-based web applications, and if it is a critical application, and during the peak time, you could see a high increase in the response time, or the throughput could be less, and the request might be high. So that can be easily visualized here, and you can plan the capacity accordingly. So you can see the average response time broken by the various multi-tier web components that will handle request consumes this much %, and MVC, that is the model view controller for the .NET applications, and the SQL DBs. Let me switch back to the presentation and discuss about the transaction elements for the performance issue. So analyzing the transaction elements for the performance issue. In the APM Insight, you can see the slow transactions, which are based on the response time. This slow transaction are the one which requires high attention so that the performance tuning or error fixing can be performed on those specific transactions by optimizing your code based on the suggestions available in the APM Insight. So let me switch back to the next slide. You will be able to see the individual business web transactions with component-wise split up. A business web transaction is made up of all the required services within your environment that are called upon to fulfill and deliver a response to a user-initiated request. These are typically things like login, search, checkout, etc. Things like conducting a search or adding something to your shopping cart or checking out will invoke various application methods and APIs, database calls, etc. Business transactions actually reflect the logical way the users interact with your application. Let me show a live demonstration of the website which I am monitoring and see how the data is captured in a real-time perspective. Let me switch back to the product and access the website which I have posted. And this is one of the website hosted on top of an IaaS server, and it's a .NET application. This is going to be in production e-commerce application, and let's see how this application can be monitored in a real-time perspective. So I was talking about the business transactions. So what do I mean by the business transactions? So as a user, somebody maybe try to logging into this site by clicking this option, and they provide their username and the password. If they provide their username and password, that would be a backend equivalent SQL query. It could be an update or insert statement which will get fired, and based upon that the user gets logged in. So this is one of the business transaction. And say for example, we are trying to read the news category here and contact us. So let's see how the data is populated in the APM Insight and how the agent collects all these data. The agent collects all this data every 1 minute, so you get a most real-time perspective of what your users were actually performing on your web application and identify if any performance bottlenecks. So let me switch back to the APM Insight and see how these transactions were populated. So let me open the application which I'm monitoring here and choose the web transaction. As you can see here that the login transaction which I have performed is already populated here in the business web transactions. And you can see the apdex code for this individual transaction, response time for this individual transaction, along with its throughput, request count, and errors. All the transactions performed by the users will be captured in case if you provide the sampling factor to be 1. So depending upon your business requirements, you can make sure to provide these sampling factor values. So let me switch back to the presentation and discuss the next topics. So response time of the individual business web transaction, that was we were discussing now, and you get to see the web request, handle components, and the individual breakup of the backend web components details were displayed in the form of graph, as you can see in this image. You can understand the slow performing queries which is causing or reducing the response time. Identify those slow database calls and find the most hit database tables, and if possible, re-index those tables for the better performance. Start fine-tuning your database performance and diagnose slow queries. In fact, enterprise applications rely on multiple components that interact in a complicated and sometimes unpredictable ways. These additional layers make it difficult to isolate the root cause when problems occur. Thus, by using the APM Insight solution, we get to see a comprehensive and a clear picture of the database performance as well. So let me switch back to the UI and see how the database calls are populated. We are in the UI now. Let me click the database tab. When you click the database tab, you get to see a complete picture of your database response time, and its throughput is again important factor for the database web servers, and the database response time by its operation. As you can see, the primary factors to be considered is the CRUD operations, the select, insert, update, delete statements. You can see those statements in detail, and database throughput by its operations, that is the specific operation, select statement, insert, update, and delete statements. So here you can again filter these database calls based upon the slowest average response time, throughput, most time consuming, errors. So let me choose sort by throughput, and you can see those queries in a detailed way. So if you could see in this image, that for this specific DB call, the index component consumes 40.76%, and all the breakup of these individual components is displayed here, which helps the database team and the applications team to optimize their DB and fine-tune their performance if there is any bottlenecks, and the database operation response time for this specific transaction and the operation throughput. Let me switch back to the presentation and discuss about the next category. So we were discussing about the databases, monitoring the databases in an overall perspective, and the individual database calls as well. The next topic is pinpointing the slow application code. So what do we mean by the application code? So these multiple application codes are tied together for your applications to be up and running. It could be a Java code, or it could be a .NET code. So these code contains an internal invocations, that is the methods or classes, and these codes were traced for the error transactions or for the slow transactions, so that the developers can optimize those SQL queries or the slow performing codes. So let's see the details available here. You get to see the traces to investigate the time consuming transactions. These traces will chart the sequence of internal methods of the URL, allowing you to drill down to the specific transaction to view the stack traces and SQL queries for slow or failed request. And you can see the trace details in a descriptive way along with its specific details, and you can drill down to these SQL statements, analyze SQL and their associated behaviors to evaluate the health of the entire business transactions, thus by reducing the mean time to time repair ratio. And you can see the details of the background transactions which needs to be monitored, and understand the contextual background of your application and predict the performance deviations if any, and get alerts before serious customer impact. You can pinpoint the application errors based upon the user transactions and get the stack traces available here. So what we meant by the stack trace for the error transactions? So exceptions is an event which occurs during the execution of program that disrupts the normal flow of the program's instruction, and exceptions indicate many types of error conditions across the application layer. It could be an out of memory issue, stack overflow issue, IO problems, null pointer exception, network timeouts, and many others. They could indicate the system problems, or in fact the problems in the application logic code, operating system level problems as well. So you get to see those error transactions with the stack traces for those error transactions. Let me switch back to the UI and show you how these error transactions are populated and how you can optimize using the suggestions available. So we were discussing about the background transactions. When you click the background tab, you can see those background transaction detail displayed here, along with its average response time and throughput. And traces is the most important factor to be considered. So here you can see the trace details available here for the slow transactions. So this is one of the slow transaction for the end user. So when I click this specific transaction, we can see the slowest components based upon these details. This helps the application owners or the concerned stakeholders to optimize their performance and re-index the code or re-index its queries based upon this. Or adding a caching in the code level helps them to optimize their application's performance. And the trace details for these specific transactions with the SQL calls and the SQL statements in a parameterized way. And we were discussing about the error transactions which we were displaying here, and all those error transactions will be displayed here with its response time and the average response time for this specific error transaction along with its timestamp. So no need to refer the logs to find the issue. All those information is readily available here. The DevOps team can just simply click this transaction and see the summary components details here. That is the slowest components along with its method details and the trace details for those error transaction, SQL statements if any, and the stack trace for the error transactions. Let me switch back to the presentation and discuss about the next topic for today. So let's discuss about APM Insight Custom Instrumentation. So what do we mean by custom instrumentation? Custom instrumentation allows you to monitor the specific block of your application code. So what do I mean by block? So your code contains a class, and inside a class, multiple methods will be available. So you can track a specific method right from the development stage itself by performing a call to that specific method, and we monitor that specific method by performing a custom instrumentation. So the link will be shared in the webinar chat panel for the custom instrumentation. So hope you can go through that. The benefits of custom instrumentation is it allows you to track your specific method captured and see the internal invocation, that is the code flow when that method is called, how the code is reacted when and the internal invocation happens based upon the code execution. And once the custom instrumentation is performed, the instrumented methods will be displayed with its execution time in the trace details tab. Let's see few additional insights for Java specific web applications. When talking about Java application, the first thing which comes to our mind is JVM. So JVM is an abstract computing machine that enables a computer to run a Java specific program. So let's discuss why JVM monitoring is important and few metrics for JVM. So the JVM CPU usage is important, heap and non-heap memory of JVM, JVM classes count, garbage collection details, thread details, and configuration details. So Applications Manager monitor the JVM's garbage collection values. So why garbage collection is important? Garbage collection makes the Java memory efficient because the garbage collector removes the unreferenced objects from your heap memory. So it is crucial to monitor the JVM. Let's see why JVM metric thread monitoring is important. Java applications in productions can have hundreds or thousands of threads running in parallel. So when an issue is detected, example, the JVM is taking very high CPU resources, the obvious next question is which thread is causing the CPU spike? And the next question is which code snippet that thread is executing. While it is important to report this information in real time, it's important that these details are made available for historical analysis for fixing this issue. So we perform the monitoring of live threads, daemon threads, peak, and sleeping threads, including the aggregated CPU and user time. So let's see the health monitor for the APM Insight itself. For Java, for .NET specific, the health monitor is a self-diagnostic tool intended to provide a snapshot of your agent settings, helps you to identify the issues occurring in the agent. That is, you can check the network connectivity, monitor the worker process, check application filters. If you have multiple applications running, you can filter those specific applications. So let me show you how that can be done. Let me open the APM Insight agent configuration. So as you can see, after installation of the agent, you have this agent configuration page available. So here, you can use this app filters option. If you have multiple applications, you can use this app filters and choose whichever application you need, and background transactions for your applications, which we were discussing earlier, and the trace settings. And you can specific custom trace settings here. And if you would like to enable or disable those transaction tracing, it can be performed here. And let's discuss about the health of the agent itself. So to determine the health of the agent, as we were talking about in this slide, so let me open the specific health monitor and show you how this looks like. So this helps you to identify if there is any agent level issue. Then you can see that the network connection is available and the .NET agent Windows service is running. And you can, if you perform a live transaction on your website, the data will be sent from the application server to the applications manager machine. So you can view the logs and repair the installation, recycle your apples depending upon your specific application changes. So these were the options available for customization. Let me switch back to the presentation and show you the end user satisfaction levels. So measuring the end user satisfaction levels. So we have discussed the various ways of measuring your web application performance from the application layer. That is, all the data which the application server receives, we monitor that based upon the business transaction performed by the user. However, these business transactions were actually performed in a web browser located in different locations. So in a real-time perspective, how to analyze these web applications in a real-time perspective when it is accessed from different locations, so that you can see if there is any ISP level, network level issues. You can in fact capture the errors, network request, page load details, and other metrics important for your web applications, and immediately test on error transactions to eliminate the false positive. You can deploy end user monitoring agents in multiple client locations and see your web application's performance in a global way. So let's see how the end user journey starts. The end user journey starts when a user sends a request from a web client browser to the web server, and then the web server responds back with the content requested by the end user. Thus, the end user journey is continued until the session is terminated by the user. It is important to analyze the user journey and how your web application is behaving for a sequence of transactions. So the end user monitoring using the real browser service helps you to analyze these metrics. So you have installed applications manager inside your data center machine, and the end user monitoring agent can be deployed in multiple branch offices, as you can see in this picture. And all you need is a secure HTTPS connection from the agent to the applications manager machine, so that the end user monitoring agent can continuously send the data to the applications manager machine. These EUM agents can be installed in different locations, as we were talking about. This EUM agent pings the applications manager server at specific time interval and sends the playback content information to the applications manager machine, which is executed from the remote location, and the results are being passed to the applications manager. Let's see how we can configure the EUM agent. So before we talk about the EUM agent, let's see how real browser monitoring works. In order to guarantee a seamless user experience, it is important to understand the user interaction with your website and how the website responds back to the request. And real browser monitoring facilitates this by providing you a glimpse of the performance of your website from the end user's perspective. Ensure each tap, swipe, or click performed is flawless for your end users. So let's see how end user monitoring agent can be deployed. So let me switch back to the UI. So here we have this specific tab called EUM, which stands for end user monitoring. So as you can see, I have deployed agents in multiple locations, that is in Dublin, New York, Sydney, and London. And I'm testing the website's performance from these different locations. So the agent needs to be deployed in these locations. The agent can be downloaded from this link available here, and you can deploy it in these specific machines. So after deploying the agent, you need a specific tool called Web Transaction Recorder. The link will be shared in the webinar chat panel. So let me open up the Web Transaction Recorder and show you how we can capture the website's performance. For that, let me log into the console. Here you have to specify the applications manager host and the actual port number of your applications manager. If you're not sure about the port, you can refer the aim-server.properties file. And the username and the password which you give for logging inside your applications manager. And now on the bottom right hand side, we have this specific option called Create Real Browser Monitor. So let me choose this specific option. And here, let me use the website, the e-commerce site which I posted in my IAS server, and see how we can capture the performance of this website. So the same website I'm using here. So let me perform few transactions in the website, and I want the same transactions to be tested from different geographical locations, and I'll show you how to do that. And just forums and blog. So all these activities, including the mouse level interactions and keyboard, has been captured. And when you click preview and save, the specific page appears, wherein you can provide the monitor name and the polling frequency, in which time interval the data has to be collected. Either you can specify it based upon your requirements, 10, 15 minutes, and 30 minutes, or 1 hour. So let me choose 10 minutes, and the page load timeout depending upon your specific requirements. And most important option to be considered is select agents, from which location you want the playback to happen. So I want the action which I have performed to be replicated in these 4 different locations, that is in New York, Sydney, Dublin, and London. So let me choose all those options and click next. You can see in this specific page that all the actions which I have performed is already captured by the web transaction recorder, which doesn't require any specific manual scripting effort from your end. So you can see those the actions which I have performed, including the mouse level interactions. And if you would like to generate an alert based upon a keyword matching, then you can specify those keywords here. Generate alert if the following keywords are not present. Generate alert if the following keywords are present. And then after verifying these details, you can click create real browser monitor. And you will be able to see a prompt here saying that the monitor has been added successfully. So let me show you the added monitor. For that, switch back to the UI. So we are in the UI now. Let me refresh the page. So this is the site which we have added now, ecom ASAP. So the playback has been initiated in those end user monitoring agents located in those specific locations. So while the playback is getting initiated, let's check some sample data available in the different locations. So I'm testing the application's performance from Dublin and New York. As you can see here, the response time and the transaction time is already displayed. And here, if you could compare these values, the response time for the same application is less or high in Dublin. So why it is high when it is accessed from Dublin? So let's dive deep into this and see how the data looks like. So you can see the average page load time and the transaction time when it is accessed from Dublin, and the page load time for the each and individual steps which I have performed. That is the multi-step user interactions, including the page load timeout value and the specific actions which I have performed, along with its screenshot. This gives you a glimpse of your website's performance from different geographical locations. So let me switch back to the presentation and discuss the key metrics of the real browser monitoring. So we have discussed about recording a web script using the web transaction recorder, and the link has been already shared in the webinar chat panel, and discussed about monitoring the critical business transactions for your workflows and performing a playback in the different end user monitoring agents, which we have already discussed. And in most apps, there are several different journeys depending on what customer choose while navigating their app. To make these user journeys easy, we need to collect the URL metrics and from the user experience point of view. The end user monitoring agent has a bundled Firefox browser in it where the actual playback happens, and the data which we show here is a live data instead of a simulated data. You get a deeper visibility into your multi-step user interactions. So these transactions were synthetic transaction monitoring, which we called, allows you to record or replay a set of simulated transactions from different locations that your user is likely to have while accessing your web application. So replaying the same transaction in UM agent on every poll helps to analyze how your transactions were performing and understand the performance related bottlenecks, if any. So let me switch back to the UI. So we were discussing about the multi-step user interactions that your user likely to have while accessing your web application. You can see that the page load time for this specific URL is quite high. So this is something needs attention, and you can compare these steps and compare metric report by using these options, which helps you to understand for a certain period of time and see how your web application's performance for the web transaction varies. So let me switch back to the presentation. So we have discussed about measuring your web application performance across the globe. So using the end user monitoring agent, you can understand your application's performance globally through easy to use graph and chart and determine if the performance is excellent or good or moderate or poor. So analyzing the response time from branch offices or customer locations is highly crucial to measure your performance. So consistently and actively monitoring the key user path that your user take is again crucial factor. You can optimize the front-end web components. You can visualize the resource size and resource count, split up of all elements comprising your web pages, that is HTML, CSS, script, image, etc., and identify which components are contributing to the poor performance of your site. A component-wise and time-wise split up of the transaction and its steps helps you to visualize and understand the transactions for better optimization of web pages. You can find the network latency using the waterfall model approach, which is available in the real browser monitor itself. It actually depicts the series of actions that occur between a user and a server until a web page is displayed in the web end user's browser. Each row represents an object. It could be a text, images, JavaScript, or any third-party components that a web page contains. Each component makes a round trip between the user to the server back to the user. So whenever one single object on this page underperforms, your user experiences will be negatively impacted. So this is crucial to monitor your applications using the waterfall model approach. Let me switch back to the UI and get some hands-on experience with this. So we were discussing about optimizing the front-end components. As you can see, the website which I am monitoring contains, the HTML contains 100%. So this is fine. As you can see in this specific image, that there is a split up of these components, that the image consumes 56.4% when this web page is loaded. If the image content is high, that could take a long time to load if the user who is accessing with a low bandwidth connection. So considering these factors in mind, you can optimize your front-end components as well. And we were discussing about the waterfall diagram, which you can see here. And you can see for this particular URL, when it is accessed from Dublin, you can see that there is a network latency of 462 milliseconds. And this data is actually taken from a browser's data itself, so which is not a simulated data again. And you can see the blocking time if there is any, and the domain lookup time, secure time, and connection time. Let me switch back to the presentation and discuss the need for end user monitoring. So why the end user monitoring is required in this digital world? With the Applications Manager end user monitoring, you will be able to understand how users navigate to your website, monitor the critical performance metrics, and maintain your SLA, create better customer experiences, and quickly solve issues by automatically capturing errors, crash, network requests, page load details, and other metrics, and also ensure to maintain your SLAs. You get a proactive monitoring to reduce the number of actual reported incidents from your end users. The playback happens from different locations, including the mouse level interactions, which helps you to replay the same set of transactions which your end users likely to have. So let me switch back to the UI and just discuss about the basic reporting capabilities of the end user monitoring. So for that, let me choose the reports tab here and end user monitoring. An at a glance report of EUM monitors across locations. So this helps you to find how your website is behaving globally for a specific applications. And you can in fact identify the outage for the specific locations if there is any, and find the minimum value, maximum average response time value for a historical period of time here. And you can again drill down to a specific application by clicking this component, and you can see the historical data available here. Let me switch back to the UI. So almost we have come to the end of this session. Let's have a quick recap of what we have discussed. So we have discussed about understanding the application performance, driving the customer journey from start to finish, diagnose, remediate, and correlate your application's performance based upon the stack traces, slow performing queries, code level diagnostic, which APM Insight monitors. Also discussed about the business outcomes by managing the user response time for all geographies of your user populations. And you can in fact discussed about the JVM specific for the Java based applications.